cross multiplying, okay? You only cross multiply when what is between the two fractions? What is this right here? That is what? An equal sign. It's not a multiplication symbol, and it is not an addition symbol, okay? We are setting these equal to each other, so what we can do is cross multiply them. Take the x and the 8 and multiply them. What do you get? 8x. That is going to be equal to whatever the other cross multiplication is. So take 3 times 4. What do you get?
12.
So you have 8x equals 12. Now this is a standard algebra problem we have all seen before. How do we solve for x? Divide by 8. So you get x equals 12 over 8 is close, but it's not simplified. Can anyone simplify 12 over 8 for me? Nick? 1.5, or if we leave it as a fraction? 3 over 2. Because both 12 and 8 have what as a common factor? You can divide both of them by 4. Okay? 3 over 2 is the correct answer. If you put 1.5, that is also correct. Okay? How did we do on number 1? Fractions aren't so bad. Okay, number 2. Number 2. Who wants to take a shot at number 2? Daniel? 12 times 5.
Equals 60.
12 times 5. And you got 60. Okay, equals what?
Equals
3x. 3x, very good. Okay. So x equals 20. You divided both sides by 3, and you got 20 equals x. Guys, not terrible, right? No. Stop freaking out. It's not worth it. You can do it. You got to believe. All right. Number 3. Diana?
X times x is 2x times 1 is 9. So 2x equals 9. Divide 2 by both sides. X is going to equal to 4.5 or 9 over 2.
Very close. X times x is not 2x. It is x to the second power.
Oh, dear God.
How do you solve x to the second equals 9? Yep. You take the square root of both sides. What's the square root of 9? X equals 3. Hey. X plus x equals what? 2x, right? Because that's 1x plus 1x. 1 plus 1 equals 2. Do you guys agree? But x times x is not 2x. It's what? X to the second power. Guys, you need to know how to do this example. Number 3 is very important. Number 6 is also going to give you a quadratic, but we do not need to know this, so cross out number 6, okay? All right, let's take a look at number 4. In number 4, Bryson, what would you do?
Multiply x plus 3 times 5.
Very good. X plus 3 times 5.
So that'd be 5x plus 15.
Very good. You distribute the 5 and you get 15, or 5x plus 15. And the other side of the equation?
And we do 2 times 3.
And you get?
6.
All right, Bryson, can you go ahead and solve this one for me?
Yeah, and you subtract 15 to 6, and that'd be negative 9.
Mm-hmm.
And then 5x, or 5 divided by 5, and then on the other side is negative 9 divided by 5, that'd be x equals negative 1.8.
Sure, negative 1.8. I'm going to leave it as negative 9 over 5. Okay? But you are absolutely correct. Give it up for Bryson, guys. Okay, anyone want to take a shot at number 5? Hannah? 36. Okay. Mm-hmm.
Distribute the negative 7 to each of those.
Okay.
You get 36 equals negative 28 plus 7.
Okay, very good.
And then you add 28 to both sides.
64, I believe.
Mm-hmm.
64 equals 7x.
Okay.
Then you divide that by 7, and I didn't get that part.
Do 64 and 7 have a common factor? No. I'm totally okay with this as your answer, guys. 64 over 7 equals x.
Oh,
That's it. If you wanted to, you can change it into a mixed number. Does anyone know how many times 7 goes into 64 without going over? I think it's 9, right? 9 would give us 63. So it's 9 and 1/7. Okay? But you can totally leave it like this. Hayden? Sure. Any other questions on this warm-up? Hey, did we get better the more practice we did? Was it like a little bit confusing at first, but now it's like starting to come back to us? Okay. Guys, we need to be able that we're getting the practice in. If you do not do the homework, you're not getting the practice that you need, okay? All right, so what we're learning about today is all about proportions,
7, then infinite.
because proportions happen when we have what's called similar polygons, okay? Now, what was a congruent polygon? What happened when polygons were congruent? Nick? They had the same measure, and they were what else? If two shapes were congruent.
They were equal?
They were equal. All of their parts were equal, and they were the same what? The same size and the same? Size and length are about the same. Angles were the same. Yeah, what else? Same size and same
Degrees?
shape, right? Like you can't have a triangle that is congruent to a quadrilateral. Do you guys agree? They had to be the same size and the same shape. That was congruence, right? Now, when we're talking about polygons that are similar, we remove one of these. Polygons that are similar are only the same shape. They are not the same size. Okay? They do not have to be the same size. Now, if they're the same shape, right, but not the same size, they still have to be proportional, okay? But not congruent, okay? Okay, so the first thing we're going to talk about is corresponding parts of similar polygons. So if you're talking about two polygons that are similar, their corresponding angles are congruent. So their angles are actually the exact same measure. So in a triangle, if you have three angles, one's 40, one's 50, one's 70, the other triangle will have to have the exact same angles, all congruent to that one. Okay? But their sides are not congruent. There's something else. There's something called proportional. And what I mean by proportional is if you put one of the sides over the other one in a fraction, that fraction will remain the same for all of the sides between both of the figures. Okay? So, do you guys remember when we were talking about congruency statements, where we would list out all of the letters of your figure and put them congruent to another figure, and I told you the order absolutely matters? The same thing happens here. The order 100% matters. So just by this statement, we could figure out which sides are proportional and which angles are congruent. Take a look at angle A. What would have to be the congruent angle to angle A in the other figure? M. Why M? It's the very first letter. What about D? What would have to be the congruent angle to D? P, because it's the last letter. Do you guys see that? So the order 100% matters. Let's go ahead and fill our diagram with all of those angles of congruence. So since these figures are similar, angle A must be congruent to angle M. Angle B must be congruent to what angle? N, very good. What about C? C and O are congruent. And P is congruent to D. Now, this symbol here is the similarity symbol. Do you remember how the congruent symbol had that squiggly and what else underneath it? An equal sign. The similarity symbol only has the squiggly. So it's saying, okay, these figures are similar, but they're not congruent, not necessarily congruent, okay? Now, if I were to take the sides and put them in a fraction, okay, all of those sides would match up. So we're going to go ahead and fill in this diagram, and we're going to use it to our advantage, okay? So take AB. Let's say I knew AB was 6 units, and MN was 2 units. What would then the fraction of AB over MN be? AB over MN would be 6 over 2. Does that simplify?
Yeah.
Sure, to what? 3. So if these two figures are similar, guys, anytime I take this fraction of 2 corresponding sides, it should simplify to 3. So if BC was, for example, 9, what would NO have to be? It would have to be 3. Because 9 over 3 is equal to 3. If AD was also 9, what side do we now know from the other figure? MP, which is 3. Yeah, what's up? Yeah. And if I told you that DC was, I don't know, 15, what would PO have to be? 5, because 15 over 5 is 3. No. Now, that factor is going to change depending on the size, right? But Hannah, if it's 3 for one of them, it has to be 3 for all of them. So if each of them was divided by 2, you know that same factor, that same proportion has to hold for the entire figure, okay? Now, the question was, does it have to be 3 every time? And the answer is no. It could be proportional by a half. Could be half of the size, right? Could be 4 times the size. That number is going to change. Could be 3/2 of the size, 3 over 2, okay? So that's what our job is, to look for that. And we're going to figure out what that proportion is by putting 2 corresponding sides over each other, okay? But does this make sense how all of these were 3? So we knew that all of them were equal to each other? Does that make sense here? Now, these two shapes are not congruent. Why? They're not the same size. They have different lengths for all of their sides. Do you guys agree? Okay. Are congruent figures similar? I would like you to take 30 seconds now and write down your answer, and I would also like you to explain it. So back it up. Go. All right, I want you to turn to the people next to you and explain your answer and talk about it. Go. 5, 4, 3, 2, and 1. So the answer is yes. Does anyone think they can back that up? The answer is yes. Christian?
I said yes if they are congruent, they're the same.
What?
I said yes if they are congruent, they are the same.
If they are congruent, they are the same what?
Everything. They have the same angles, same sides.
They're the same angles, the same size. But what do you need in order to be similar? Bryson?
Needs to be equal to each other.
What has to be equal?
Like,
Their shapes.
because
Juliet?
When you divide like AB over MN and they're both the same number, like 6, 6, it's going to be 1.
Very good. The proportion is all 1. The proportion would be 1, right? And that's what it means to be similar, is that it's proportional. And if it's congruent, it has to be the same what? We're missing one word. That's very important. I wrote on the very first slide. It's the same shape. Okay? It's the same shape because congruence means same shape, same size. And if it's the same size, then its proportion will be 1. Okay? So congruent figures are similar. Are similar figures necessarily congruent? That answer is no. So congruence is only one small possibility in all the possibilities of all similar shapes. Okay? How are we feeling?
Good.
Are we okay? Let's do an example. Well, before we do an example, let me introduce something called the scale factor. Now, I need you guys up at the top. Please write a little star. The scale factor, you're going to see this a lot. It's going to be referenced by a lowercase k. Okay? So we're going to say k equals whatever. And that means that your scale factor is that number. Okay? If two polygons are similar, the ratio of corresponding sides of two similar polygons will be your scale factor, your k. Guys, what is a ratio? Kind of like probability, yeah. It's just like a fraction, okay? So it's like this compared to this. So your ratio, right, of corresponding sides, we're going to take two sides that are corresponding and put them in a fraction, okay? And that will be our scale factor, all right? So let's go ahead and take this figure, right? These are two triangles, and they're both equilateral or equiangular, right? So our scale factor is pick two sides that match up, that are corresponding to one another, and put their lengths over one another. So what are two sides that match up? AB matches up with what? ED or FD. Now, in this case, it doesn't really matter, right? Because all of the angles are congruent. So technically, any of these sides could be the match, right? But in other figures, it will matter, okay? But in this case, we can say, okay, AB is proportional to ED. So let's write it as AB over ED. And what was AB's length?
What is K?
K is your scale factor, right? What is AB? 3. And ED was what?
6.
Can we simplify that fraction? It's 1 over 2, right? This is your scale factor. Now, who's to say we couldn't put ED as the numerator and AB as the denominator? Couldn't we do that? So what else could also be my scale factor? Flip 1 over 2. What would it become? 2 over 1. So your scale factor is 1/2 or 2. It doesn't matter which one you put, okay? Now, there is one specific example where there's only one scale factor, and that's what I'll get to on the next slide. But if it just generally asks you, what's your scale factor, right? You can say either 1/2 or 2. Now, look at this. Doesn't that make sense? Wouldn't you say that this triangle is exactly half the size of this one? Because all the sides are half of it, right? And wouldn't you say that this triangle is exactly double the size of this guy? So doesn't that scale factor kind of make sense? You can always go back and look, am I doubling each of my sides? And the answer is yes, yeah.
Well, like, isn't half double just 1? Like, what would you, how did you get, like, 2? Or, like, what did you do?
How did I get to? Well, let's say we wrote it as ED, right, over AB. Because I didn't tell you what to use as your numerator and what to use as your denominator. What was ED's length, Daniel? 6. And AB's was what? 3, right? What's 6 divided by 3? 2. So you see how we get the scale factor as 1/2 or 2 depending on what we made our numerator and our denominator?
So it depends on the order.
I'm telling you it doesn't matter. You can put 2 or 1/2 and they'll both be correct. As long as you match up corresponding parts. Okay? Good question. All right, guys. In the next example, it wants us to find our scale factor. Just put a K there on top of scale factor of ABCD to MNOP. In this one, it gives us direction. The first shape will always be your numerator. Put an N over it for numerator. And guess what the second shape then has to be? Your denominator. So this one is not just generally asking me what is the scale factor of these two figures. Do you see how it gives me direction? We have to follow that direction throughout the entire problem, okay? So what I always do is I always put an N and a D on my figure. So I know this is my numerator figure, this is my denominator figure. So an N goes on this one and a D goes on this one. That way I can never mess up this entire problem. All right, it wants me to find the scale factor. So in order to find the scale factor, you need to figure out, okay, I need two sides that are corresponding, and I need to know the length of both of them to figure out my scale factor. Which two sides are corresponding in these two figures, and you know both of their lengths? MP and AD. Very good. So MP and AD. Now, you cannot write MP over AD. Why does AD have to go on the top? It's from the numerator figure. Do you guys see that? AD is on this left side, part of the numerator figure. MP is on the right side, part of the denominator figure. Yes?
Is A, B, C, D the numerator because it's bigger?
Nope, it's because it came first. You see how it said find the scale factor of A, B, C, D to MNOP? Whichever one comes first is always going to be your numerator. Okay? All right, so now we just fill in the lengths. What was the length of AD, guys?
10.
It was 10. And what was the length of MP? 8. So this is my scale factor. Put K equals. And how can we simplify 10 over 8? You can divide them both by 2. So what's my scale factor? 5 over 4. We're done with the first part. Now, for this problem, I told you on the last one, if we put 4 over 5, would it be correct for the last problem? Yes, because it was just generally asking me the scale factor. For this one, it gave me direction. Do you guys agree? It said this one first to this one. 5 over 4 is my only answer. Do you guys understand that? Okay. The second one says, find x, y, and z. So how we do this is, remember, all of your sides are proportional by that same scale factor. So what we're going to do for B is we're going to say, okay, this is letter B, excuse me. 5 over 4, which is my scale factor, should be proportional to all 3 of the missing sides. So we're going to set up 3 proportions. One involving x, one involving y, and one involving z. Let's do x's proportion first. So for x's proportion, x is represented by NO. Do you guys agree? What is the corresponding side to NO? BC, or 4. Which one goes in the numerator? Which one goes in the denominator? 4 goes in the numerator. And what goes in the denominator? X. Do you see how the consistency matters? Because if you put x over 4, I guarantee you're going to get the wrong answer because you're using the scale factor wrong. Okay, let's set up y's. How do you solve for y? What do you set up for y? 5 over 4 equals? Not 14 over y. 12 over y. Because what's the corresponding side to MN? And you can also use your letters. Do you see how AB are the first 2 letters? Those correspond to NM. Do you guys see that? The first 2 letters. Okay? Remember, order matters. Use it to your advantage. And the last one for Z. 14 over Z. So now comes into play what we did in the warm-up. Do you guys remember the warm-up? How do we solve these guys? Cross multiply and divide. So we're going to take 5 times x, which will give me 5x, and we're going to set that equal to 4 times 4, which is 16. How do you solve for x? Divide by 5, so x is equal to 16 over 5. And guess what, guys? It doesn't simplify. That's our answer. You can leave it just like that. You can leave it like that. All right, I want you guys to try to solve for y and z. We're going to go over them in a second. Go. Okay, the answers are on the board. Y was equal to 48 over 5. Z was equal to 56 over 5. Guys, help the person next to you If they got one wrong, help them find their mistake. You have 30 seconds, go. If you both got them, talk about how you got them. Make sure you guys did it the same way. Yeah. Guys, are we Gucci on the cross multiplication and solving process? Yes. Okay. So we did part B. So we're done with part A. We're done with part B. Next comes part C. C is asking me to do what? Find the perimeter. How do you find the perimeter, guys? Add all of the sides. So ABCD is going to be fairly simple. To find the perimeter of ABCD, we just add all the sides. It should be 12 plus 4 plus 14 plus 10. What's 12 plus 4? 16, right? And then 14 and 10? 24. 16 and 24, my perimeter is? 40. It's 40 units. All right, let's find the perimeter of MNOP now. Okay? So this is going to be perimeter equals. What is the only side that we knew to start? 8, right? So put 8 plus, what did we get for Y? 48 over 5. What did we get for X? 16 over 5. And what did we get for Z? 56 over 5. How do I add those fractions together? Yeah?
First, you have to multiply 8 by 5 over 5, so it's the same. Like we added everything else.
Very good. 8 needs to get a common denominator of 5. Do you guys agree? And the equivalent of 8 with a denominator of 5 is what? 40 over 5, right? Because if you take 40 divided by 5, you get back to 8. So we're not changing the value at all. We're just writing it a little bit different so we can add it with the other ones. So plus 48 over 5, plus 16 over 5, and plus 56 over 5. Go ahead and add all of those together. Let's see what we get. We're going to get 40 plus 48, which is 88 over 5. And then the 16 and the 56 will give me 72 over 5. You add those together and you get P equals 160 over 5. 160 is divisible by 5, and I believe it's 32, right? Okay, so my perimeter of ABC was 40, and my perimeter of MNOP was 32. The last part of this example in letter D says find the ratio of the perimeters. What's a ratio again? A fraction. Now, which one goes in the numerator? The 40. Why does the 40 have to be my numerator? Look back at your figure. Do you see how I put an n there? I put an n there for a reason. Anytime we set up a ratio, the numerator has to come from that figure. So that figure's perimeter was 40, right? So put 40 over 32 and simplify it. They're both divisible by 8. And guess what? What fraction do you get? 5 over 4. What else was 5 over 4? The scale factor.
So what was your scale
It's
factor?
always the same. How cool is that? So, and think about it, right? Like, if one figure is going to be 5/4 the size of the other figure, wouldn't you agree that adding up all the sides, it should still be 5/4 the size of the other one? So, you can absolutely use this method to check at the very end, like, did I do all of my sides correctly, okay? And it will always work 100% of the time. Kind of cool, right? All right, so the ratio of the perimeters will be the scale factor. If you want to write a little note to yourself, that was K as well. Matches. It matches K. I cannot spell today. Matches. We're almost done, guys, I promise. I promise. How are we doing? Okay? All right. Corresponding lengths in similar polygons. So what this slide is talking about, it says if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Guys, we're going to use this for two primary examples, for medians and for altitudes. And all this slide is saying is it's saying that your scale factor not only applies to all of the sides of the triangle, but it also applies to any length inside that triangle. So if the sides are proportional by doubling it, your altitudes are proportional by doubling it as well. Okay, so whatever that scale factor is, it applies to altitudes and medians. So check it out. In the diagram, it says TPR is similar to XPZ. Find the length of the altitude PS. All right. Guys, first and foremost, make one of yours your numerator, one of yours your denominator. Which one should I make my numerator? Okay, and which one should I make my denominator? XPZ. Now, find your scale factor. Do we have a set of corresponding sides between these two triangles? We do. Which two sides? XZ and TR. Very good. Which one goes in the numerator? TR is going to be over XZ. And I'm saying this should be equal to what? My scale factor, right? My K. All right. Now, what is TR going to be? It's 12 because you add the two sixes together. What is XZ's length? 16. Does that scale factor simplify?
Yes.
Sure does. It's going to be 3 over 4 because they're both divisible by 4. So I just found my scale factor. And it's asking me for what? The altitude, which is what length between what 2 points? PS. So let's make that X. So remember, you set your scale factor equal. 3 over 4 is going to be equal to. Use the altitude of the triangle on the right and the X. But which one needs to go in the numerator? X needs to go in the numerator over 20. Very good. How do we solve this? Cross multiply. 3 times 20 gives me?
4x equals 60.
60 equals 4x. Very good. And then you divide both sides by 4. X is equal to? 15. That's it. Makes sense. Okay. How are we feeling? I know we're tired. Are there any questions about this? You sure? Ask me now. Okay, guys. Last thing that we need to learn is that, and we already talked about this, your perimeters, and this is our first theorem of chapter 8, your perimeters are similar according to the scale factor. So do you remember how we did that problem in example 1, where we found the ratio of the perimeters ended up being the same as the scale factor? That's true for all similar polygons, okay? So if you added up all of the sides of one polygon and it was similar to the other polygon and you added up all the sides of the other one, it's going to be proportional by the scale factor. Slide. Possibly. Yeah, I did talk about that one, did I not?
Yeah.
Okay, perimeters, right? We already discussed that in example 1. They're proportional by the scale factor. The second theorem, theorem 8.2, is the areas of similar polygons. This theorem says that they're not proportional by the scale factor. They're going to be proportional by the scale factor squared. Okay? So if our scale factor, for example, let's use the scale factor from the last problem. Wasn't it 5 over 4 for the last problem? Or from that initial problem? Our areas are going to be proportional by that scale factor squared. What happens when you square 5 over 4? Isn't that just 5 over 4 times 5 over 4? How do you multiply fractions? Straight across, right? What's 5 times 5? 25. And what's 4 times 4? 16. So this is how your areas would be proportional to one another, by the scale factor squared to the second power. Now, I know a lot of students, they prefer to just think of this as 5 squared over 4 squared, and that's fine. They just put 25 over 16. But this is where it's coming from. Yeah, Diana.
Did you skip a slide or am I going crazy?
Did I skip are proportional by the scale factor squared? Okay. Now, so if we're looking at example 3, this is our last example. In the diagram, G, H, J, K is similar to L, M, and P. Find the area of L, M, and P. First thing you do is put an N and a D somewhere on your diagram. What do you want to be the numerator? All right, this is going to be our numerator. Then what's the denominator? This guy over here. You have to put that down first so that you're consistent the entire problem. Are we clear? Okay. So, first thing you need to find, we need to eventually find the area. Which one do we not know the area of? So, area is equal to, give it a variable. What variable could we use? A. Little a for area. I like it. Area is going to be equal to little a. And we don't know it, right? So let's put a question mark there. All right. First thing you got to do is figure out, okay, what is my scale factor? How do I find my scale factor? Ooh. My K is going to be 7 over 21. Why? Why is that my scale factor? What is the scale factor? What is the scale factor in general?
The ratio?
The ratio of what? Corresponding sides. So do you guys agree that KJ, based on the order of these letters, KJ is these two letters? It should correspond to NP, based on my similarity statement. So do you guys agree that these two sides should be proportional? So if I put 7 over 21, okay, that's going to be my scale factor. Always what with your scale factor? Simplify it. What are 7 and 21 both divisible by? 7, right? So it's going to be 1 over 3. So now I take my scale factor, and what do I have to do with it to compare it to areas? Square it. So we're going to take 1 over 3. We're going to square it, and that will be proportional to the areas over each other. What area must go in the numerator?
84.
84. Do you guys see that 84? That was the area of the numerator's figure. Over what?
X. Oh, A.
A or X, whatever you made your area variable. What is 1 over 3 squared? Remember, it's 1 over 3 times 1 over 3. 1 over 9. So 1 over 9 equals 84 over A. How could we solve this guy? Cross multiply, you're sure right. This isn't A, by the way. And then 9 times 84, I did this already. It's 756. And 1 times A is just A. So my area is 756. Let's make sure we get the units right. What do the units have to be? Meters squared. This is my answer. Are we okay?
Yeah.
Are there any questions on this guy? All right, your exit ticket. What other name could you give for the ratio of corresponding side lengths? Scale factor is the answer. Write that down and then turn these in. What letter represents scale factor? Little k. Perfect. Turn these in, and then that's it.